Hello, hello. In this next video, we're going to talk all about the almighty router. We're going to talk about plunge base, fixed base. We're going to talk about feed rate, direction of cut, collars, collets, climb cuts. And if you've seen any of my videos, you know there will be much, much more. So yeah, let's dive in. So a question I get asked a ton is, what router do I start with? Well, that's a good question, but it depends on what you're doing. If you were doing only Formica work, right, plastic laminate, you could get away with a little trim router, right? Now, I gotta mention, I love corded tools. I have a lot of cordless, but those are my screw guns, drills, you know, a grinder, flashlight, angle drill, stuff like that. My routers, I want a cord on them. I like the consistent power. I don't want to stop mid-cut because my battery died. That's just me. Now, these three routers is what I would categorize as a small, medium, and a large. These are fixed base, which means the base is, you know, removable and it's adjustable in height, but it doesn't plunge like a plunge router. We'll talk about that in a bit. This is a fantastic router here. This is a Makita. This is a RT0701C. Of course, it's corded, but it's variable speed, soft start, has the capability of accepting collars, which we'll talk about later. Fantastic little router and only about $100. This one is a workhorse in my shop. This is a medium-sized Porter cable. I don't have the base on it now, but the base I do have for this router will also accept collars. Most of them are going to accept the collars, but check that first, and maybe it'd be a good idea to get a collar set to begin with. And we'll talk about that as well. This is one of my large fixed base. I have two of these. I actually have three because I have one that's just the motor in my router table. This thing is a beast. And if you're doing a lot of big, heavy cuts, you need a big router. Now, there are tasks that I do sometimes that I could actually use a medium size or even a small router, but I may choose to use a large router like this simply because a router this size will reduce vibration because of its overall mass. So in general, I prefer 1/2-inch shank bits. Of course, this one will only accept quarter. This one will accept quarter or half, but in general, I like 1/2-inch shank bits because of their mass, less vibration. That all makes sense, yeah? When it comes to routers, a plunge router is a very versatile machine because you can do so much with it. You can do all the things that a fixed base can do. In addition, you have the plunge capability, which is great for doing inlay work or pocket cuts or template work where you don't want the bit exposed all at once. You can drop it down incrementally. This one's variable speed here on the side. Of course, the base will accept the collars. So yeah, this one is a beast of a router, but you might not always need something this big. That's where a smaller plunge router like this is the model 450, also Porter cable. This thing is a beautiful little tool, pretty accurate, and has the plunge capability, which I absolutely love. This is great for doing inlay work, or looks like I have a 5mm bit in here, and you could use a template and plunge holes for shelf pins by using that template. Quick, easy, accurate way to do that. So yeah, gotta love plunge routers and their capabilities. So this router, or one comparable to it, would be a fantastic first router to get. Not only is it a plunge router, you can actually switch out the base, right? You can do that real quick. Release the lever, pull the motor out. And incidentally, when I'm using plunge routers, I like making one of these. It just makes it quick and easy to set your router in place, and you have access to your plunge depth rod, stop, and all that. Makes it convenient. Anyway, back to this dude. We can add this fixed base. This goes on there. How beautiful is that? So one router came with both bases. I seldom use this one. It's mostly set up with a plunge base, but with the two bases, it makes it extremely versatile. All right, so a good collar set is going to make your versatile router even more versatile. These are extremely useful for making, for doing template work. And so essentially what this does, this collar, this serves as a guide. So this would go around your material that you're cutting. Let me do it with this one better. Right, and perhaps you have a straight bit, you're making dados, you would have a straight edge, you would have the straight bit would be making the dado or the groove, and the collar is following the straight edge. I have two sets here. This one is older. I don't use this one as much. I prefer this one. I don't really even know why. It's brass. And typically these come and they have a really long barrel, kind of like this. And you can see most of these I've ground them down. You can see how much shorter that is. See how short that is? I just grind those down. The reason I do that is most of the templates that I make, I use 1/4 inch material, and here's why. If it's a wavy cut or some kind of a pattern, well, to remove that material is much easier as 1/4 inch than it would be something thicker. And with the reduced barrel of the collar, I can go around that 1/4 inch and I don't have to worry about all this material hanging down. And it doesn't hurt anything if I'm following a thicker pattern or straight edge. So I've got this collar marked shelf pin, and with this collar in place, let me add this dude, a couple of pins there that need to engage this slot. Maybe if that was released, there we go. So now with a template like this would go on the material. Of course, you'd have it all lined up, and I can have the collar engaging in this template. Boom, make a cut, make another one, another one. Very effective for if you don't have, a boring machine that does 54 of these at a time. This is a good alternative. Incidentally, if you do use a router like this to cut shelf pins, just get a straight bit, not a spiral bit. A down cut or an upcut won't work for plunging very well. You'll want just a straight double flute router bit, something like that.
But of course, in a 5mm or 1/4 inch, whatever shelf pin size you have.
All right, let's talk about feed direction, rotational direction, all that jazz, yeah? So with a handheld router, if you're needing to know which way the bit is spinning, think of it like this. Hold out your right hand, your thumb will represent the router bit, your fingers represent the direction of the cut. So you can see the router in this position or at a router table, the router motor is spinning this direction, right? And this is testament to the fact that the cutters, the way they're positioned, would need to rotate that direction to properly make the cut. So if you're using it handheld, conversely, the router's upside down, rotate your hand over. This represents the router bit again. My fingers represent the direction of the motor spinning in this direction. You can look down. Yep, that makes sense, right? So if I'm using a handheld router like this, I know that the router bit is spinning in this direction, clockwise, right? Which means as I'm going around a workpiece, I would be going counterclockwise around that workpiece because my router bit is turning this direction clockwise. And as it's spinning, those cutters are cutting into the work. So that's the correct orientation that you would move a handheld router around a workpiece. So this is a great time to talk about climb cuts. When would you do a climb cut? What is a climb cut? So we've already established what the normal direction to route around a board would be. When I'm using a handheld router, I will be moving the router counterclockwise around the workpiece. Incidentally, let's say this was a cutting board and I wanted to put a chamfer or a roundover on it. I see a lot of people starting right at the corner and on long grain, and they work all the way around, they come around, and as they approach this final corner, if your router bit is dull, or depending on the species of wood, there's a lot of factors, this last cut could split out this corner, because remember, the router bit direction is spinning like this, and as it hits this vulnerable corner, it can flake that corner loose. So a better place to start would be in the middle, and typically you would start on end grain. So you could start right here in the middle, go around, you're going all the way around. As you come here and approach this corner, that is not going to splinter out. This hasn't been routed yet. You make that cut, you end up right in the middle where you started. Everyone's happy. There are situations where you can use a climb cut to prevent the wood from splintering. And again, the species will make a difference. Oak is notorious for splintering out. Cherry is pretty forgiving, as is walnut, but you can see the grain direction running off at an angle here, right? So if that router bit is spinning in this clockwise direction, it's catching these wood fibers as they come out as at an angle, and that is an area that would be prone to splintering out. So to mitigate that, or to eliminate that, you would do a climb cut or a reverse cut. And essentially that means you would be going this direction first, and then you would follow up with a regular cut. So with a climb cut, as I'm bringing the router this direction, even though the router bit is still spinning the same direction, my feed direction is opposite. So as the router bit is spinning like this, it doesn't have the propensity to catch this material and splinter it out. That makes sense, right? You can see, obviously, if I'm going this way with this grain coming off at this wanky angle, it could catch that and splinter it out. Moving it this direction with a climb cut, it's less prone for that splintering to happen. Now, you should be careful when you're doing a climb cut, because the router will want to grab, and it could literally pull the router out of your hand if you're not expecting it. So have good control. Don't take too deep of a cut. It should be a light pass. Get used to that climb cut and the way the router is going to react. All right, so how fast should you be moving the router? Well, it really depends. It depends on the material. It depends on the router or the motor size. How new is your bit? You know, is it sharp? Is it a new bit? Is it dull? How much material are you removing? All those factor in to feed rate, how fast you're moving the router. Many times you can literally just listen to the router and it's going to tell you, yes, I'm comfortable with this feed rate. Keep doing what you're doing. Or it's screaming bloody murder and it sounds horrible. The brushes are sparking and arcing. It sounds bogged down. You can hear the router complaining in so many videos. Usually what is happening is people have an undersized router and they are making too big of a cut. And sure, it's doing it. They're showing everybody, hey, look what I can do. I'm routing out these windows in this OSB plywood with a tiny little battery powered router, and they're feeding way too fast. The bit's probably dull. The router sounds horrible. And all that adds up to meaning you're going to shorten the life of your router, plain and simple. So listen to your router. You'll get used to hearing what sounds normal and what sounds like you're literally killing this little dude, right? So generally just a smooth direction of cut, smooth feed rate. If you go too slow, you'll start seeing burning. If you're going too fast, you can literally create more problems with the wood splintering out or making the router suffer. Something that you're going to have to get used to the more you use the router. So this is a really cool accessory for a router, and basically all it is a collar, right? But this is an inlay kit, and it utilizes this extra little collar, has a little rubber O-ring. At least I think it does. It did, yeah, it does. It's in there. And that holds it onto this. And basically this two-part system allows you to create inlays. You can see this arrow that I put on the back of these drawers. And I didn't use an inlay kit to create this, but this is where it would have worked. For me, it was faster to do it by hand. But you would essentially make a jig, something like this. And with this inlay kit, this piece goes on here. You follow this around, and this makes the cavity with this part of the kit in place. And you wrap this center, right? You make a cavity in the drawer box, and then you would remove this. And the width of this part of the collar is an 1/8 inch, so you would have an 1/8 inch bit in your router. You put this on, and you make the cut into some material, maybe some cherry veneer or whatever, and you would end up with this piece. And then that will fit directly right into that perfectly. Maybe a little bit of fine tuning, but a very cool little kit, a router inlay kit. I actually use this to make the cavity in the drawer box, and then I cut these, a bunch of them at a time, stacked them all together, cut that angle, and then just rounded the ends and put them in. To me, it was faster than cutting one of these one at a time, since I had a bunch of drawer boxes to do. And I'll show that in an upcoming video, but still, an inlay kit would have worked perfect for that. Let's talk about collets for a second. Not a collar, but a collet. This is a 1/4 inch collet. I've got a 1/2 inch here. Go ahead and take that out. Special wrench, I just cut one, welded it on here, and with that, I can just simply put that in place. Just makes it easy. Boom. Right? To tighten it, I just reverse the position of the wrenches. So that tightens. Then I can go right against this again. Boom, tight. Anyway, let me get that out of there. So in order for a collet to seat properly, this is a conical piece. The corresponding area here is also conical. Those mate perfectly. As the threads draw that tight, it compresses these parts of the collet and it tightens against the bit. Pretty simple concept. The problem I see a lot, well, when I was production manager, some of the guys would have problems with router bits slipping. It was always the same culprit, a dirty collet. This needs to be clean. You have to get the dust out of there. If there's, debris in there, if you get sawdust in there, this can't do its job. Occasionally, this can get rust that needs cleaned. So yeah, you gotta keep that clean, super important. 1/2 inch collet, 1/4 inch collet, they all work the same way.
A chamfered tenon is going to serve two purposes. A, it's going to make insertion much easier, right? And two, it's going to prevent the glue from being squeegeed off the sides of the inside of the mortise. So yeah, a small router with a chamfer bit is an excellent way to achieve that. So this may be already well known, but I've seen some dangerous methods being shown on how to make a round dowel, any species you want. And you're only limited to the size of the roundover cutters that you already have. So after cutting a piece of stock material to size, I establish two square faces, or two faces that are adjacent to each other, right? And then we can zero in this case, to 3/4 of an inch or 0.75. Incidentally, if you ever have a bunch of pieces, multiple pieces, and they all need to be the exact size, rather than just checking one, stack a bunch of them together and then divide that by the number of pieces you need. That'll give you more accuracy because any incremental error will show up. All right, so let's get a router bit in here. And since I'm making a 3/4 inch dowel, that's the diameter, I need half of that, which is a radius, so I need a 3/8 radius round over bit. Incidentally, you may have noticed these 4-wing cutters for roundovers are excellent. Pretty straightforward here, utilizing something straight to set up the fence flush with the router bearing. I always make sure and blast this little screw adjustment out. It gets full of sawdust. And yeah, this is the Woodpecker, I believe the PRL V2, the Precision Router Lift. I absolutely love this thing. Super easy to set up and adjust. I've had it several years. Superb. All right, here we go. So what you want to make sure is to leave two flats, or flats on the ends of the workpiece, I should say. That keeps everything stable. I'm using a gripper push block and just leaving the flats on the ends all the way around, 4 sides. That'll keep the dowel from rolling as you make the cuts. It looked good, but I took it outside and noticed that each roundover wasn't quite connecting. So I moved the fence or raised the router a little bit deeper, I'm not sure which, but made the dowel perfectly round, and I'll show you what I'm doing here. So this is a project I was working on last year, and I needed a flat surface to set up a workstation for the Shaper Origin. Cutting all these veneers, it needs to be dead flat, and my small workbench, which I wasn't using at the time, is a nice flat surface, but I didn't want clamps in the way because the veneers were pretty long, and so I thought I would use dowels inside the bench dog holes to hold everything in place. And I really didn't know if this would work, but I knew what I wanted, and it turned out fantastic. Superb place to use the Shaper Origin. It's nice and flat, and it's almost always ready to set up, or it's almost always set up, I should say. And there we have it. I kind of went off on a tangent here, but I was making 3/4 inch dowels utilizing a router. And speaking of routers, there's a beautiful Shaper Origin. So routinely I will make my own dominoes. I have a video on that. I'll leave a link in the description. And incidentally, if you ever see me or anyone anywhere doing something that you don't feel comfortable with, don't do it. It's that simple. I'm very comfortable with this, and I just wanted to make a test piece. That's why I was routing the ends. I wanted to show you could stand your piece up so that you're going the same direction to create that roundover on the end.
Hello. So a couple of router tips for you. First of all, route outside when you can, right? Because it's a mess. Second thing, I like using this stuff a little bit on the base. Just makes that glide much easier. And I'm cutting a large cove. You can see this. I'm going to do it in several passes, maybe 4 or 5, and I just incrementally work my way down. Always do a climb cut. When I'm doing the climb cut, I put the pressure on this side of the router. And then when I do the forward pass, I put it on the opposite side. And then I'll do a final pass with just even downward pressure. Hope that makes sense.
Well, that's it for this video. I sincerely hope you got some use out of it. Please remember to like and subscribe if you haven't done that already. And as always, thanks a ton for watching. Now, routers is a huge subject. I didn't cover all of it. If there's any questions and I get enough questions that maybe I can make another video explaining some of the, responding to some of the questions, I'd be happy to do that.